this tutorial, let us confine ourselves with the solving of one-way ANOVA problem. At the very outset, let me tell you that I am going to state only the steps manually solving the problem. Just follow the steps. If you want to have a soft copy of this problem with solution, you shall contact me using my email ID given in the description. This is the problem. A study examines the impact of various fertilizer types on plant growth measured in centimeters. 4 distinct fertilizers are applied with 4 plant groups receiving each type. The growth measurements are as follows. Fertilizer wise: X1 10, 12, 11, 13, X2 15, 14, 16, 13, X3 9, 8, 10, 11, X4 12, 13, 15 and 14. At a significance level of 0.05, is there a statistically significant difference in mean plant growth among the various types of fertilizers? First, understand the problem and then proceed to state the hypothesis. Null hypothesis. There is no significant difference in the mean growth of plants. mu1 equal to mu2 equal to mu3 equal to mu4. Alternate hypothesis. There is significant difference in the mean growth of plants. mu1 not equal to mu2 not equal to mu3 not equal to mu4. After stating the hypothesis, go ahead to solve the problem. State the problem as it is given. X variables x1, x2, x3 and x4 stands for the growth of the plant groups treated with different quality of fertilizers. Populate the columns with values. Already I have stated the observations, so I need not repeat the same. Now find the sum of values, that is sigma x, otherwise known as T, for each column. They are 46, 58, 38 and 54. Arrive at the grand total of all the sums, that is sigma T. It is 196. Find sigma x squared, otherwise known as T squared, by squaring the column totals. They are 2116, 3364, 1444 and 2916. Find T squared by n by dividing T squared values by the number of observations of the respective samples, that is 4. They are 529, 841, 361 and 729. Arrive at the grand total of all the three values, that is sigma of sigma T squared by n. It is 2460. Have a separate table to have the squared individual values in the primary table. Name the headings as x1 squared, x2 squared, x3 squared and x4 squared. State the squared values. Find the total of each column. They are 534, 846, 366 and 734. Finally, find the grand total, that is sigma x squared, 2480. We have finished the basic calculations. While calculating, I have shown the values in a skeleton form, but it is always good that you have an empty table like this. and then start calculating. That will give a neat and impressive look to your work. The main calculation begins. The first value to be calculated is correction factor. Correction factor equal to sigma t whole squared by capital N equal to 196 squared by 16 equal to 38,416 by 16 equal to 2,401. Here capital N is calculated as follows. Capital N equal to small n times C, where capital N is total number of observations in all the samples put together. Small n is the number of observations in a sample. C is the number of columns, that is number of samples. In our case, small n is 4, C is 4. So 4 times 4, 16. We shall calculate sum of squares of total variation, that is SST. SST is equal to sigma x squared minus sigma t whole squared by capital N. We know the value of sigma x squared. It is 2480. Sigma t whole squared by capital N is the correction factor. Already we have calculated the value. It is 2401. Then 2480 minus 2401, 79. Next, we shall calculate sum of squares between sample or column variance, that is SSB. SSB is equal to sigma of sigma t squared by n minus sigma t whole squared by capital N. Sigma of sigma t squared by n is 2460. This we have already calculated. Sigma t whole squared by capital N, this is correction factor. It is 2401. Substituting these values in the formula, we have 2460 minus 2401, 59. The final value we have to calculate is the sum of square of within column variance, that is SSW. The formula to calculate SSW is very simple. It is SSW is equal to SST minus SSB. We have all the values. They are 79, 59. By substituting and simplifying, we get 79 minus 59, 20. Now we shall proceed to fabricate ANOVA table. In the present case, it is 4 by 5 table, that is 4 rows and 5 columns. In the first column, we are going to state the source of variations. The sources are between samples, within samples and total, that is all sources. In the second column, we have stated SSP value 59, SSW value 20, SST value 79. In the third column, we have stated the degrees of freedom. The SSB degrees of freedom is C minus 1, that is number of columns or samples minus 1, 4 minus 1, 3. The SSW degrees of freedom is total number of observations in all the samples, that is capital N minus C. You know what is C? It is the number of columns or samples. 16 minus 4, 12. The degrees of freedom of SST is capital N minus 1, that is 16 minus 1, 15. In the fourth column, we have recorded the mean square between columns or samples. It is MSB equal to SSB divided by degrees of freedom. 59 divided by 3, 19.7. Then we record the mean square of within columns or samples. MSW is equal to SSW divided by degrees of freedom. It is 20 divided by 12, 1.7. In the last column, we calculated the F value. It is MSB divided by MSW. 19.7 divided by 1.7, 11.59. Now it is time to compare the calculated F value 11.59 with table F value. For this, you must know the significance level. It is 0.05. It is given in the problem. We are in need of numerator degrees of freedom, that is, degrees of freedom of mean square between columns. It is 3. And the denominator degrees of freedom, that is, degrees of freedom of mean square of within columns. It is 12. And finally, we need ANOVA table. While choosing the ANOVA table, we must select that table meant for 0.05 level of significance. The relevant part of the table is shown here. The numerator degrees of freedom are stated in the top first row of the table with yellow color. Move to 3. The denominator degrees of freedom are stated in the leftmost first column of the table with yellow color. Move to 12. Then look for the value by moving inside the table. It is 3.49. Our conclusion is, since the calculated F value 11.59 is greater than the table F value 3.49, the null hypothesis is rejected. The inference is that the fertilizers differ in quality. To identify the best quality fertilizer, we have to go for post hoc test. I shall discuss it in some other video lesson. We shall meet in the next video lesson, in which we shall discuss how to solve the same problem in Excel.